So this is the talk Outsmarting the Smart City. If you're not here to see smart city hacking, you're in the wrong place. So without further ado, let's get on to introductions. My name is Daniel Crowley. I am a research baron at X-Force Red. You might be wondering why I have a silly title. It's because I wanted to be research director, but apparently director is kind of a reserved word at IBM, so I couldn't really put that in my title. I pitched tyrannical research dictator. They didn't really like that. We went through a couple other iterations, but there were some various concerns about all of them. And then I pointed out that I hold the noble title of Baron in the micronation of Sealand. So long as you recognize the sovereignty of Sealand, you know, Imere Libertas to you, then I hold a noble title there. I've been doing pen testing since 2004, mostly focused on application security, although I have a big interest in physical security as well. I've done a lot of that, but
I'm Jennifer Savage. I'm a security researcher at ThreatCare. We're a small startup. I'm also a member of the Black Hat Review Board, and I have a number of years of experience in tech involving development, vulnerability assessment, vulnerability management, penetration testing, security research, management, consulting. I could go on.
Hi, my name is Mauro. I'm manager consultant for IBM X4 Red. I'm very passionate about finding new flaws and finding errors. I've been working for many years. I have many years experience as a pen tester. I have experience as a developer, architect, and server administrator.
So you might be wondering what kind of tech makes up a smart city. You know, what does the term smart city technology actually mean? So there's a wide range of different technology. Some of it is industrial systems, and the sort of connection of industrial systems to more traditional like IP-based networks. You have urban automation. So one example being automated waste management trucks that will drive around and identify trash cans with RFID tags so it knows which cans have been put out and picked up, what the weight on each of them was, to sort of manage, you know, waste pickup. You have public safety and emergency management technology. So things like surveillance systems and alarm systems and disaster warning systems, detection and preparedness. You have intelligent transportation systems technology, which helps to reduce traffic congestion and help a city, you know, be easier to traverse by road. And then you have, in some places, metropolitan area networks, like maybe public Wi-Fi or public-facing internet kiosks.
So when it comes to the privacy of smart cities, I think there's a lot to consider. It's a very different thing when you're in your home and you choose to have an IoT device or choose not to. And it's a very different thing when you walk outside your door and every light post is also a camera. When you have a vehicle to infrastructure hub that can monitor where a particular vehicle is in the city at any time. There are a lot of privacy concerns there, and citizens don't always get the choices that they should, you know, or that they do in their own private home. So you can choose not to have an Alexa, you can choose not to have a smart TV, you can choose not to have a cell phone, I guess. You could buy a really old car. You could move into the middle of nowhere, I guess. But if you already own your house in the city you live in, I mean, that's kind of a large ask. So you don't always get to choose what's in your city.
I see we have a fan of really old cars in the audience. So speaking of cars, yeah, woo! So we have so speaking of cars, there's one of the most interesting areas of smart city tech is the intelligent transportation systems. So there's all these things sprouting up: vehicle-to-vehicle communications, vehicle to infrastructure, vehicle to anything. And so we looked at some of that, and we'll be talking about that later. But there's some interesting privacy developments there. You know, generally, you can tie a particular vehicle to a particular person. For many vehicles, the only person who is ever going to be driving that vehicle, for the most part, is a single person. So if you can track the location of a vehicle, then you can track the location of a person. And if you can track the location of a person, you know something about what they're doing. Because, you know, nobody goes to see an oncologist who hasn't got particular health problems, in general. So there are definite privacy concerns that are closely tied with intelligent transportation systems. One interesting thing that's been proposed is the next version of the OBD, or onboard diagnostics system, where it's wireless and it includes features such as the ability for law enforcement to immobilize a vehicle wirelessly. Now, that has concerns even when used by law enforcement, but when you start to enter when you start to entertain thoughts that these systems might be hackable, well, there's different concerns there. Now, again, speaking about traffic, there is a project in Hangzhou, China, called the City Brain, or Traffic Brain, and it is a huge intelligent transportation systems project that tries to manage the huge traffic problems that they've had there. And it's been very successful. It's reduced traffic congestion by a great amount. But there are, of course, privacy concerns. And I saw this quote that kind of disturbed me as a Westerner. In China, people have less concern with privacy, which allows us to move faster. Now, for context here, this is a talk about the City Brain by a guy from Alibaba who worked on the City Brain, who's talking about the City Brain. So, yeah. And then, one of the easiest things to see where there might be privacy implications is surveillance cameras. There's some very hard to see cameras, some very covert cameras in streetlights. These smart streetlights will sometimes have cameras in them. In a lot of cases, a lot of these smart city technologies, it's very cheap to just stick a camera on it as well. So it's a thing that does X, Y, Z, and it also has a camera on it. So that's interesting. But people seem to want to put cameras on everything. And speaking of that, the former head of Singapore's civil service was quoted as saying that Singapore wants to put cameras on every single lamppost in the country and use facial recognition software on them. That's all 110,000 lampposts in Singapore. And if you think that's a little bit nuts, Dubai wants to have a police station manned entirely by police robots in 2030. I think there was a movie about this and it didn't end well.
So how do you discover what's actually in a particular city and what's out there in general? It turns out the bar is pretty low. You can just use search engines. So various device manufacturers will publish customer case studies where they talk about how their device is used, where it's being used, and go into a fair amount of detail about that. Additionally, you can look at local news reports. A lot of news reporters are really fascinated by the developments of adding smart city devices to a particular city, and so they will just cover what's happening. Cities also have open data initiatives where you can go and see what kinds of data these devices are producing, and they publish it's available for anybody to use. You can write apps based on it, and there have been some really great apps written based on the data provided by these initiatives. And then additionally, in the US at least, these contracts are public by law and they're FOIAable. So you can search for the word purchase order, and smart city device, and then the city name, site.gov, you can check BidNet, etc. Additionally, there's also these great search engines out there. which aren't for searching for websites, but are more for searching for internet infrastructure. So if you can identify a city's IANA range, then you can go and check Shodan and Census and these other websites to see, you know, what they actually have deployed in their IANA ranges. And lastly, physical recon. So this one involves visual observation, what's out there, what's on the side of the street, what's on that light post, what's on top of the parking garage you just parked in, etc. You can always do the traditional wireless recon like war driving methods, but not just for Wi-Fi, but for other bands as well. So the unlicensed bands, Zigbee, LoRaWAN, etc. And then all of this requires that you log off and just go outside. And lastly, this is, I think, really cool. A lot of smart city initiatives, the code is open source. So you can do things like search GitHub, Bitbucket, GitLab. And then this one website we found called OS80P, the open source application development portal. And it's an initiative with the Federal Highway Administration. So you can just go and get the source code for these projects. Makes it a bit easy. So just real quick to go over my home city, Austin, Texas. I used all of these methods to see what was in my city. There are news reports where they go into detail. Here's some of the headlines. So the Smart Street on 6th Street, it's a big party street, right? Transit shuttles that they're considering. And then there's this one website called CityUp where they document what they're doing. It's pretty cool. I highly recommend checking out CityUp. And then Census here is the IANA range for Austin. You can see a list of devices. Some of these aren't being used for smart city devices. Obviously, there's all kinds of infrastructure up on their range, but you can see some in there as well. And then on the side of the street, we found some cool stuff. So this is a flood sensor. It's on all the low water crossings in my city, and it just detects flooding on those low water crossings. And then there's a website, ATX Floods. Everything gets transmitted wirelessly, and then it updates a map of what areas are flooded so citizens can plan a route around the city. Interestingly, after we started our research, they added the ability to check cameras to verify. They put cameras at all the low water crossings so you could verify the sensor reading visually. And then here's an example of just searching Google for a purchase order. This one happens to be for, what was this one for?
Body cams.
Oh yeah, police body cams. So that falls under the safety portion of smart city devices.
Interestingly, they've, in addition to purchasing body cams, they've also purchased an evidence.com subscription that allows cloud-based storage of body cam footage.
Yeah, maybe they're using it. Anyway. Here you go.
So let's talk about the devices and their vulnerabilities. So the first devices we'd like to talk about are in a family of devices called the ILON devices. Now, if you've done any review or any study on industrial control systems, ICS gear, SCADA stuff, you know that the state of security in ICS is generally, if you can talk to it, you can control it. So the general recommendation around this is to prevent anybody from being able to talk directly to ICS devices. So the point of ILON devices is to hook up ICS devices to IP networks like the internet. So we saw this and we were like, we got to test this. So this speaks a number of different industrial control protocols like LawnTalk, which these devices are from the Echelon Corporation. LawnWorks, LawnTalk, these are creations of Echelon Corporation. But it also speaks, Modbus and Modbus over IP. It speaks BACnet, BACnet over IP rather. And it can also speak to SOAP-based web services. So you can control a number of devices with the ILON smart server and its successor, the ILON 600, from across the internet or, on an IP-based network. So we picked up one of these and set it up, and I'm not an electrician, so I was really nervous the first time I plugged this thing in. You should have seen me. I was like wearing like safety goggles and oven mitts, and I was like plugging it into one of my external power outlets outside just because I wasn't sure if I was going to cause a fire. But no fires. We got it working all right. We found a number of vulnerabilities. First thing we noticed was that there were default credentials. The username and password for these devices is Ilon. So with Ilon, you can get into either the web application or the FTP server. But in case that has been changed, the API that actually does all the heavy lifting on the Ilon is actually unauthenticated in the default configuration. So the user interface that has some JavaScript that lets your browser talk the right way to the API, that's authenticated, but the actual API calls are not. So if you make them directly, you can bypass the authentication. Now, if somebody has actually noticed this flaw and changed the configuration to, let's say, authenticate the entire web application, there's multiple problems. There's the fact that the communication is in plain text, so you can see the basic authentication being used and just pull out the username and password by base64 decoding. But more than that, there's also an authentication bypass flaw. So what happens is that the paths are just simply, it's just string-based matching. So if you request /forms/echelon, well, we'll get into that in a second. But once you're in, you can get the clear text password because it's stored in the configuration file via FTP, or you can replace the binaries on the device to execute whatever kind of code you want. You can simply use the device as the original administrator would have used it to fiddle around with ICS gear. And you can also just lock people out of being able to use this by changing the IP address in the interface. So the authentication bypass kind of looks like this. So you'll see that we're requesting forms echelon setupip.htm. And this is just the IP configuration page for this particular device. And here it is telling us, very sorry, but you have to authenticate. Now, what it's doing here is, on the first line after get and before HTTP, that's the path that you're requesting. And it actually just does string-based matching on that against what's in the configuration file. So in this case, in the default configuration, anything that starts with /forms/echelon is authenticated. But if we just add a second slash in between forms and echelon, then the string-based matching is broken because it's not /forms/echelon, it's /forms//echelon. So now we're not asked for authentication. And once this reaches the operating system level, it removes the extra slash, like, what is this doing here? I don't need this. It gives the same file anyway, and it works as it should. So that works on both the Ilon Smart Server and its successor, the 600. Interesting, the API, missing authentication on the API doesn't work on the 600. The other thing is that using the authentication bypass on the Smart Server versus the 600 gets you different things. In older versions of the Smart Server, back when it was still called the Ilon 100, the device would actually allow you to get the FTP username and password in clear text through the API. They fixed that at some point and made it so that you couldn't get that information, but you could still change the FTP credentials. So you could use the unauthenticated API to change the FTP credentials, then log in via FTP and replace the binaries, backdoor the device, whatever it is you're going to do, you know. On the 600, they have this thing called security access mode, which requires you to actually physically walk up to the device, push a paperclip into a button, and reset the device while holding the sort of security button. And that boots into a special mode which allows you to change the sensitive configuration parameters like the FTP. So the authentication bypass is a little bit less impactful on the Ilon 600, but one thing that you can still do is change the IP address and lock people out of it. And you can still use the ICS gear through the Ilon device. So you can still fiddle with ICS gear, maybe put it into some unstable or dangerous state, and then change the IP address on the Ilon device, and somebody has to physically walk to it with a paperclip and push it in before they can fix it, which is suboptimal. Furthermore, we found what appears to be a leaked exploit from August 2015. We found this on some GitHub gist, and it mentions that they found this ages ago, and this exploit used the unauthenticated API to pull the FTP username and password, then log into the FTP server and pull the clear text web application username and password. It's not clear where this comes from, how long ago they discovered this, but it was at least posted in August of 2015. So this was something that somebody knew about for at least 3 years. And when we spoke to Echelon Corporation about this, they had not heard of this. We were the first one to bring this to them. So that kind of tells us that other people are looking at this too.
Patel V2I Hub. What it does, it manages communication between connected vehicles and transportation infrastructure. It translates data from multiple sources and protocols used in transportation. It has a modular infrastructure. The system can help to deliver messages that are useful to connected vehicle applications like red light violation, speed warnings, or override warnings. With V2I Hub, we can have access because it has a hard-coded admin account. It has different API key issues. You can perform cross-site scriptings. Executing SQL injection in the API is also possible, and you can gain access with authentication as well. With all these flaws, an attacker can do many things. He can track vehicles, he can send false messages, he can create traffic, or just shut down the hub. And this shows why it is possible to shut down a device that's running this software, because it doesn't require any key, it doesn't require any cookie, and it's just running OS command to shut down the server or the device. It has an API, and this API requires a key. If this key has been changed, it is possible to request the API through the web server directly without authentication. And we can see using a string compare function. Even if the key file was restricted, the input and the correct key are being compared using the string compare function, which has an odd set of rules or return values in different situations. It mostly makes sense. However, when they're comparing strings and arrays, something interesting can happen. The string compare function returns null and a warning. If this warning is ignored, something can happen here too. When it's 0, the string function compare and return. When two strings are identical, it's compared to null. This comparison returns true, as long as you're not checking types too careful. This means if you add a square bracket to the left and right square bracket to the end of key, in the URL, any key will be the right key, and you will be able to bypass the authentication and request any value in the API. For version 3.0, it was also possible to execute SQL injection without authentication and extract users and passwords as well.
So the last device that we took a look at is called the Libellium Meshlium. So the Meshlium and the ecosystem that it fits into is a sensor system. And actually we have one here that we'll be showing you in a moment. The Meshlium is a device that connects sensors to of various kinds to cloud platforms and to databases. So it aggregates sensor data and stores it for use by some other system. What we found with this was that there were several endpoints that were not actually authenticated. They were called by some other script that was asking for authentication, but it was also possible to invoke them directly and skip the authentication. And more than that, there were shell command injection flaws that just directly took user input values and fed them into shell commands without any sort of sanitization. So you can see here in the last line of this little snippet, it just simply takes a post variable directly from user input and concatenates it onto the end of a shell command and executes it. So if the value of the link post variable is semicolon rmrf/, then it deletes all the files on the file system. Or, sorry, semicolon sudo rmrf/, probably no preserve root as well. But you get the idea. You know, this is a one-shot shell injection bug, and the web application user also has sudo privileges with no password, so we have basically a one-shot root shell command execution exploit, pre-authentication, very reliable. And so we've built a little dam here, a simulated dam. Jen, can I get your phone flashlight?
It's not ready yet.
Oh, it's not ready yet. Okay. So we've got a simulated dam here. So the way that we've set this up, we've got the libellium meshlium here, and we have a wasp mode plugin sense with an ultrasound sensor. Now what this is doing is detecting the water levels in this simulated dam and river type scenario. And we have a Raspberry Pi that's polling for the sensor data that's sent from the wasp mode to the meshlium. So it's constantly polling the meshlium for new water level data, and every time the water gets too low, you can see it opens up the dam gate and more water starts to pour out. And every time it gets too high, it starts to restrict the dam gate to close it off a little bit. So it's kind of trying to keep this equilibrium where the water level doesn't get too high and doesn't get too low. Now, thank you. So, little ghetto lighting rig. So what we're going to do here is to use the vulnerability that we found. We've written an exploit that corrupts the sensor data and inserts fake data that suggests that the water level is very low. It's maybe about a foot or two below the top of the table here, which is obviously not possible, but that's what the sensor believes, and so it will react accordingly by opening up the dam gate all the way.
You ready?
Ready. So we can see now that the dam gate has opened all the way up and water is starting to pour out of the dam, even though the water is reaching the top of the riverbanks and now starting to flood the side of the river. So, and this will continue on because the system still believes that the water level is drastically low. I don't know why these cars aren't driving away, but turn around, don't drown, save yourself. But here they are, and you can kind of see if you have the right scenario, the exploitation of these flaws could result in some pretty serious consequences.
If you could move the camera over so everyone could see the whole device.
Well,
yeah, it's flooding.
Yeah. Anywho, thank you. So we'd like to be clear that we're not aware of any system that this models exactly. Governments are a bit tight-lipped about exactly how they've deployed things. We do know that this device is used for flood prevention in South America. We know that it's used to detect radiation levels around nuclear power plants in Spain because of case studies published by the manufacturer. But we're not sure about the details. We wanted to show one possibility of what could happen if this data was trusted absolutely with no redundant systems, no human checks. The consequences are potentially serious.
So I just want to real quick get into the implications of our research. I think a lot of them are pretty obvious, but just to go over it. So surveillance of vehicles. You may think it's not so important if somebody watches wherever you're going throughout your city, but when you're talking about VIPs like a governor or a celebrity or maybe even the president, the ability to watch where they are at all times could be really important to an adversary. Traffic manipulation. So, if you have a wartime scenario, oftentimes spies will be sent overseas, to an adversary's location and will do things to interrupt the supply chain. So one of those things could be traffic manipulation, and now you could do it potentially completely remotely. And then this one's, very similar to what we just showed in our demo, but sabotaging disaster warning systems. So if you could force a city to evacuate because they thought that the city was flooding with radiation, that could have a pretty big impact. Or if you could just suppress a warning. So if you could just keep flood sensors from going off even though there was flooding. And then, sabotage of industrial equipment and the gateways, just like what Dan was talking about earlier with the ILON systems. So
don't forget your paperclip.
Yeah, don't forget, after you've hooked up your city as an IoT, with all the IoT devices in your city, don't forget to make your paperclip an IoT device too, so you can reset the device. No, I'm just kidding. But, cities could be doing more here as far as making sure that the devices they purchase have been tested. At the very least, you should be able to get a remediation plan from the very last pen test for a particular device. You should be able to see that the device is being tested yearly, or even, every 6 months, just on a regular basis. And cities should probably also have their deployments of these devices tested as well and make that information publicly available so people aren't afraid of what's going on in their city that they may not know about.
So I also would like to mention, because we forgot to put it in the slides, that there is some amount of security due diligence that's on the deployment of these devices. To give an example, we found about 450 ILON smart server devices exposed to the internet. And at the time of our research, we could have backdoored every single one of these devices if we were malicious, which it's good we're not. At this point, I think we're done and we can open it up to questions. Does anybody have any questions?
Do you want to come over to the microphone? What's our time?
So are vendors for industrial control systems, do they have a consortium? Are they taking this stuff seriously? It just seems that a lot of the same issues I hear year after year as far as weak default configurations, poor coding practices. Are they living under a rock the last decade? Are they actually working together trying to improve some of this technology?
I know that there have been some efforts to try to improve industrial control systems security, of which, that's involved in smart city tech as well. That's a subcomponent of it. I know that there has been a cert formed specifically for ICS devices as by DHS, I believe. So there are efforts to improve industrial control system security, but I'm not aware of any sort of security consortium. That doesn't mean it doesn't exist. I'm just not aware of any. Thank you.
I'm going to call out that that does exist. It's the Electrical Power Research Institute, or EPRI, based out of Knoxville, Tennessee.
Great.
They do all kinds of cybersecurity and full-on ICS, SCADA hardware validation across the board, if any of you are interested in their work.
Great. Happy to hear that. Thank you.
Hi. In your research, did you find any good examples of vendors doing good security or like good deployments while researching this topic by any chance?
Oh. Everything we looked at was pretty bad, unfortunately. That doesn't mean that there aren't well-protected smart city devices out there. It's just that everyone we looked at was, you know, OWASP top 10, you know, bingo. So, whether that says something about the state of smart city security as a whole, probably, but who's to say? We could have just picked devices and got very lucky to find, lucky for a security researcher anyway, to find ones that had serious, easily exploitable flaws.
Thank you.
Since smart city technology is pretty new or is beginning to be implemented, are there any lessons that you guys feel could be implemented from other domains like smart home technology or wearables that apply to smart city technology that people that are designing these cities could use to implement security measures?
Absolutely. I think implantable medical devices is one thing that smart city technology vendors can learn a lot from, because once something is implanted in someone's chest, you don't really want to have to do surgery to update it. Similarly, when something is encased in concrete, you don't really want your update process to involve a jackhammer.
I mean, I think that from an IoT perspective, there's been some great initiatives at the federal level for testing these devices, consumers report style tests of these devices, and it could be expanded. You could also test smart city devices in that effort as well, and I think it would be a great public service to do so.
Just making sure this is on. What did you do with the information that you found during your research? Did you contact the companies? What was their response? Just trying to figure out how that was in reporting those bugs.
Right. So we did report all the bugs. As soon as we were sure that these bugs were exploitable, we reached out to the vendors. They responded relatively quickly. Every one of them, I think, responded within a week or a week and a half, something like that. They responded positively. They, you know, understood that these were flaws and that they needed to be fixed. They issued patches within, I think the one that took the longest amount of time took like 3 weeks to a month. So it was, as far as bug disclosure usually goes, a walk in the park. And I'm really happy to say that. I'm glad that at least that is sort of like a silver lining to this all. That, you know, it seems to be that at least the vendors understand the seriousness of the flaws and want to fix them. So, you know, happy ending, kind of. Any other questions? Well, if you have questions and you just think of them right after we leave the stage, you can come to the IBM booth in the business hall, and we'll be there for a little while to answer any further questions. Thank you.
Thank you.